Well, good morning, everybody. How are we all doing this morning? I see some folks are already saying hello in the chat, which is lovely. Any other people who are already tuned in? It's not quite 11 o'clock yet, so we won't get started just yet. Although I probably should mention that I have posted a Top Hat question, and you are very welcome to start answering that anytime. Oh, not a lot of people saying good morning just yet. In fact, it looks like we have a low number of viewers. Oh, now it's starting to jump up a little bit. Right, so for those who are just joining us, good morning. We do have a Top Hat question that is already in play that you can start answering. In the meantime, maybe people can say hello in the chat. And also, I guess I'm a little curious as to how people found the midterm on Tuesday night. People are typing. Love to see that typing. Question. Could I show the question? Yes, indeed. All right, so hopefully that is helpful for people while I'm showing that. And there's not a whole lot of action happening in the chat this morning. Things are a little bit quiet in that respect, but I don't know, maybe people are just ready for the midterm break. So we are going to talk today about more things to do with lists. I should say that the midterm, we've started marking the midterm. It's almost half done at this point. So there are some questions that are completely graded. There are some questions that are like 10% graded. There are a few students actually who the various questions being graded, actually we've got all of their midterm graded. And out of the, oh, sorry, you can't see the rest of the question because of my face. Yes, that is fair. The part that I was blocking was the word compound expression. Okay. So someone says 2006 has not been set up. Yes, so I'll just repeat for those in 2006. The thing that I'm saying earlier. Okay. For those who think that Mun Wi-Fi is not working, so there was an update that went out a few days ago, and if you saw it on Newsline, that's great. If you aren't subscribed to Newsline, you probably should. Newsline is really, really helpful. It sends out useful information. There was a wireless update the other day, and you do need to accept the new certificate that they give you, and really, really irritatingly, speaking as someone who is a privacy and security person, they don't give you the fingerprint of the new certificate in advance, so you just have to blindly click, yes, I accept it, because whatever. And that is terrible and awful and wrong, but unfortunately, it's the way that things are at the moment. So you do need to accept that new certificate if you're trying to log in on Wi-Fi. And for those who are in 2006, I posted a message in the chat. Our SI leader is not there today, but anybody can use the computer at the front of the room and turn on that stream on the podium. So I'm going to put my face away again so that people can continue answering that question. So I was saying that we have started marking the first midterm, and we have so there are a few people, maybe about 10 people for whom their entire midterm has been graded already. And for those students, we have a range of marks ranging from 96 at the high end, which is fantastic, down to like 27 at the lower end, which, is obviously less encouraging. So when you do get your midterm grades back, which will probably be next week sometime during the break, do have a look and see where you can learn something from questions that went wrong. And if you're at this point in the course finding that you're really, really struggling and you're really not sure what to do next, then by all means set up a time to like chat with me or something, and we can try to figure things out. But we certainly don't want anybody to be struggling, and the course, we're going to get into more and more things which are going to let us write cooler and more interesting and more exciting programs, but we do need that strong foundation of the stuff we started with. So if you find you're struggling, do get in touch. Someone said, what are we trying to answer? You are trying to answer the question that is currently visible on the live stream. And if you don't see it, if it's not popping up on your device or whatever, then don't worry too much. We will still assign it as homework so you can do it afterwards. And in fact, I'm going to close this question now because, well, I want to be able to move on to the things that we're talking about today. So let's have a look and see what people said. So how can this factorial be simplified with a compound expression? So taking whatever the current value of factorial is, multiplying it by number, and saving that back into the variable called factorial. And the answer is, there we go. So there are a variety of ways one could, oops, in the correct answer I wrote plus equals. I'll fix that. It's supposed to be times equals. Yes, so factorial times equals number. So we had something that looked a little bit like this on the midterm. There was a question that some students said, is that even like legitimate code? And the answer is yes, it is. There was a place where we said something minus equals something. Remember, we introduced these compound expressions, which are just a way of simplifying that very common expression of something is assigned by itself plus something else, minus something else, times something else, divided by something else. That happens so frequently. We have this syntax, which is a compound expression, which just combines those both together. So if you had I is equal to I plus 1, or put in another way, I is assigned by I plus 1, we can just write that as I plus equals 1. In that example I just showed you, if you have factorial is assigned by factorial times number, well, we can simplify that by saying factorial times equals number. And so that is a nice, simple syntax for just not having to repeat ourselves so often. All right, so today we are going to talk about more things to do with lists, and then we're going to finish out the first half of the course, and we'll move off into the midterm break. So, today, we are going to remind ourselves of things that we've done with lists thus far, and then we're going to move on to some new things, being list comprehensions and a little bit of additional syntax. So far we've seen how to create lists. So what's the syntax for creating a list? Someone type in the chat. What does it look like? If I had a list that contains the numbers 1, 2, and 3, what would that look like? Well, we have typing that is happening. Yeah, there we go. So, for example, if you created a variable called x that contained the numbers 1, 2, and 3 in a list, you would have open square bracket 1, 2, 3, close square bracket, and then that could be assigned to a variable called x, someone suggested, or we could just have an expression, which is a list. List 1, 2, 3. And that can be an expression all by itself. It doesn't have to go into a variable. So good, those are good answers. We have talked about how we iterate through iterable things, which can include lists, but it can also include strings. So what is the kind of loop that we use for iterating through things? In that chat, go ahead and type it. What do we use for iterating through things? Yeah, for loop. Good. And then last time, just before the midterm, in things that I said we would not, that you would be welcome to use on the midterm if you found them helpful, but you would not be required to use on the midterm, we talked about indexing and slicing. So if we want to look at an element in the middle of a list or in the middle of a string, then we can, and we can take slices of these things. Okay, so why do we use lists? So what are some good reasons to use lists in our programs? There was one place where on the midterm I asked what type should you use to represent all of the titles of all of the books on a shelf, for example. And if we've got multiple books, then, well, we might use a string to represent this book's title and a string to represent that book's title, but we wouldn't use one string to represent all of the book titles. We wouldn't have a string to represent computer systems, a programming perspective, dark territory, social engineering, the art of deception, sandworm, the Clue Train manifesto, etc., all these other things that are on my bookshelf. That wouldn't be one string. We would have a list of strings. So that is one example of why we would want a list. And so Oh, someone says, we were having some technical difficulties in EN 2006. Well, no worries. So far, I was mostly just chatting about the midterm, and we had one top hat question, which will be assigned as homework, but now we're actually starting to talk about the material for today. And if you want to catch up what you missed about the midterm, then you can go back and look at it later. So, but why do we want to have lists? What is a reason to use lists? Any reason? I guess one would be because your professor told you so. Why might we want lists? Some people are typing, that's good. Right, to store lots of values. Very good. And in particular, to be able to store an arbitrary number of things. So sometimes when we're trying to solve a problem with programming, we will have a fixed number of things that we need to work with. So remember when we did the exercise that involved the Engineering 1 promotion average, where I said there are 9 courses that you should input grades for, and then you are going to compute something for those 9 grades. You're going to compute the average of them, and you're also going to check to see if any of them is less than 55, and that'll tell you if you're promotable from Engineering 1 or not. Well, what if you don't have 9 grades? So, in fact, some of you probably in this class don't have 9 Engineering 1 grades because you may have done A-levels and have brought in A-level credit for Physics 1051 or something. That's a pretty common thing. So depending on your high school background or maybe you went to a CEGEP and you have transfer credit for things, or maybe you went to the College of the North Atlantic or the Marine Institute and you did some math courses or some science courses or some English courses and you came into Memorial with transfer credit. Well, if that's the case, then you might not have grades for all 9 of those courses, but you should still be able to graduate or to be promoted out of Engineering 1. So it is a very, very common thing that we need to write programs that can deal with an arbitrary number of things. So we might say that however many Eng 1 courses you have, we want to compute the average of those, and we want to make sure that none of them is below 55, but for whichever grades you have, we'll just calculate the average of that many. So that's a good reason to use something like a list. And also, in some cases, even when we know in advance how many things we're going to have to store in a list, even then, sometimes it can be a more elegant way to represent things in a more general sense. So, for example, I know that there are 120 students in this course, and therefore I expect to have 120 grades for midterm 1. So I could have 120 separate variables to store those, and I could do that. But I think it'd be a lot more convenient if I just stored those 120 grades in a list instead. Even though I know exactly what the problem size is, it kind of seems silly to write a program that can deal with exactly the right number, but then next semester when we have a different number of students in the course, we have to rewrite our program. That seems really silly. So a list is a useful way to store lots of things inside of conceptually one thing. So one variable that represents a bunch of stuff. Okay. And so when we did exercise 3, we didn't know about lists yet. Well, I mean, some people may have known about them from previous exposure or something, but I didn't assume that anybody knew anything about lists. So I would have expected you to write something kind of like this. NG1010 is equal to, let's take the input of the NG10. I'm so used to typing NG1020 that it's hard for me to type almost anything else that starts with a 10. Like, it's a real muscle memory kind of thing. And I would have expected you, to write things kind of like this. So input the grades for NG1010, NG1020, NG1030, NG1040, and other stuff, right? And we would have had to write our program that way if we weren't going to use lists. So how could we improve this by using a list? Right? So then we might say that the average is equal to NG1010. See, I can't even type it. NG1010 divided by plus NG1020 plus NG1030 plus NG1040, all divided by 4, and we'll print the average. There we go. So I could run this program. And today we're in lecture 13, right? Yes, we are. Okay. So I could run this program and say you got a 97 in NG1010 and a 55, no, hopefully not, 95 in NG1020. Maybe you got a 55 in NG1030 and an 82 in NG1040. All right, so your average is 82.25. Very good, that's acceptable. How could we do this differently using a list? And of course, the way that you wrote it, there would have been more repetition because you would have had other courses too. Someone's typing. 2 people are typing. That's good. Okay, marks in a list. Okay, so one thing we might indeed do is start by having an empty list, right? Actually, first, no, let's do this the right way. So we're going to have some kind of a loop that's going to over and over and over do something. So we're going to have a loop that does something. What is the something that we need to do over and over and over again? We can try to represent that in like pseudocode. Haha, someone says the lab yesterday, lol. Okay, very good, very good. Yeah, you did some of these things in the lab. So what's the step we need to do over and over and over again in this loop? If we're inputting a bunch of marks, what do we do for each mark, for each one? Okay, so we're going to input a mark. Yeah, so let's see. So the grade equals next grade. Oh, and by the way, I noticed that on the midterm, some people tried to do this. What's wrong with this line? Input, int, next grade. What's wrong with that? Right, int should be first, but why? What does this do? Well, this tries to take the string next grade, it passes that to the int conversion function and says, let's convert next grade to an int. That's going to give us an error. What we actually want is to take next grade and pass it to the input function and say, dear input function, go get us some input from the user, please. And then take whatever it returns and pass that to the int function. Okay. In fact, let's do it this way. I'm going to break into 2 steps, and you'll see why in a minute. Next grade, grade equals int, okay. And then someone said we probably want to add that to a list, which means, well, I guess we're going to have a list. So our grades will start out as an empty list, then we can append something to the list. And one way we can do that is with our plus equals syntax. So we can append 2 lists together. So 1, 2, 3 plus 4, 5, 6. This is going to create a new list that has the elements 1, 2, 3, 4, 5, 6 in it. So this is called, for those who are following along in the PDF version of the note, we can add 2 lists together with the plus operator, and this is known as list concatenation. Concatenation, it's a very fun word. It's a jargony word, which means that we can use it with people who are familiar with the word because they're taking the same course. It's probably not a great way to explain a new concept to someone who doesn't understand programming, but it is technically the right word for what we're doing when we smush 2 lists together. So this is list concatenation, and it's one way to make our lists change size. So we're going to start out with an empty list, and then after we input a grade, it'll have 1 element in it because we took an empty list and we added it to a list that has 1 element in it. What's a longer way to write this? I used our compound operator syntax there. What's a longer way to write the same thing? Someone's typing. So the answer is we could write it as grades is equal to grades plus, grade, sorry. Yes, somebody pointed out there that there was indeed a little spelling error here. So this is a list that contains one grade, and that grade is the grade we input from the user. So I could write this the long way. Grades is equal to grades plus grade, or equivalently, goodness, typing in front of people is hard. Equivalently, I could say grades plus equals a list that has one grade in it. So let's run this and see what happens. Actually, sorry, let's debug this and see what happens. Right, loop is an invalid syntax, sorry. So we thought about the thing that has to happen every time we go through the list, but we do still need to think about how do we get into it and how do we get out of it. So how many grades do we want to input here? So from exercise 3, the answer would have been 9. So how can we know that we need to keep going in this loop? Under what circumstances should this loop keep going? Right, so there's a couple of ways that we could do this. One is indeed to say for I in range 9, so we'll go through the loop once with I being equal to 0, and then I being equal to 1, then I being equal to 2, etc., all the way up to 8. So 0 through 8, that is 9 iterations. We could use a while loop here, though, as well. We could say while the length of grades is less than 9. Either of those are fine. So let's try running this now. So we start out with an empty grades variable, or a variable called grades that contains an empty list. Then we are going to step into this while length of grades is less than 9, which it is. We're going to input a grade, and I said that grade was 97, I think. Convert that to an integer. So now you see we have grades is a list that has no elements in it. Grade is a variable that has the number 97. Then we will evaluate the expression on the right of this. So create a list that contains grade. What's grade? Well, look in this variable, it's 97. So we have a list that contains 97, and we're going to concatenate that with grades. So now grades contains 97. And so let's continue through here. I'll enter the next grade, and I think it was 95. And you'll see now we have a list that contains 97 and 95. The next grade was 55, I think I said. We go through, and the next one was an 82, something like that. And so now you see we have grades has 4 grades in it. Now this is going to keep going and keep going and keep going. Let's say you got 100 in something, and then you got a 90 in something. And you notice at this point, I don't even really care which course we're talking about. It's just 9 grades. You don't have to have a different mark in this course versus that course. Let's say a 75, 100. You did really well in something. And at this point, I think the length of grades, so we take that list, we pass it to the length function. It is 9. 9 is not less than 9, so we're done and we break out of that loop. Okay. Then down here, how do we compute this average? People are typing, which is good. Sorry for those who are watching at home, but if you're watching at home, you should also be typing. Okay, yeah, so we have in Python, as we mentioned previously, a function called sum. And so indeed, we could say that the average is equal to the sum of our grades divided by what? Right, so I could say divided by 9, because we know that there are probably 9 grades at this point. But if I want to be a bit more general, yeah, there we go. divided by the length of grades. So if indeed we have 9 grades and the script as it's currently written, we definitely will have 9 grades, we could have just said divided by 9. But I want to add something else here that makes this a little more general, because what do we do about a student who has transfer credit, right? Suppose that a student has transfer credit for physics 1051 or something. What can we do then? Well, usually on a transcript that'll be represented with that is often represented in our internal systems with a letter T for transfer. So what we might want to do is check if the next grade is T, then we don't want to try and convert that into a number. Instead, we just want to skip to the next grade. So how can we do that inside of our little loop here? So there's a couple of different answers. Yeah, okay. So we can check. If the grade is equal to T, then maybe we just continue. Another way of saying that is if the grade is not equal to T, then we do this stuff. And in fact, maybe we even collapse those two lines together. There we go. Now, there's a potential problem here, which is using the while loop. You see, there's a possibility of an infinite loop here, because now I could enter grade of 1, 1, 1, 1, T, 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 and grades will never get to be 9 grades long. So maybe we do want to use that for I in range up to 9. That's one possibility. Another possibility is we could keep that while loop, but instead of checking to see if grades is equal to T, maybe we could say if somebody enters done, then we break out of the loop, say, sorry, there are no more grades. So there are like a lot of different ways one could tackle this problem that would all be equally correct. So let's say I'm doing it this way. So my grades are 97, 95, 55, and 82, and maybe everything else is transfer credit, so I say at this point we're done. Well, now we compute, and look, we got the same average that we got before. Okay. Good. Any questions about this? So we've seen a couple of new things here. Right? We've seen how we can use the plus operator to concatenate lists, kind of stick them together, join them together into one list. And we've also then, we've designed another algorithm that uses a loop. For my money, I would probably most prefer to do it this way, which is the same way that a couple of students suggested in the chat. There we go. But the other way is absolutely fine too. And I like to do it this way because here I know that this loop will only repeat 9 times. There's no way that I could make a mistake inside of here that turns this into an infinite loop. So that's kind of why I like that way of doing it. But other ways can also be correct. Just slightly riskier, perhaps, but also correct. All right, I'm not seeing any other questions popping up in the chat. So let's continue then. So something that we see an awful lot, a very, very common pattern when we are writing code that involves looping over things like lists and strings and other things that are iterable, ranges, is very, very often we see something that kind of looks like this. And this is another way we could have implemented this. Instead of having, and actually, I'll show you very quickly, another way we could have chosen to implement this is instead of storing all of the grades, we could have stored a total and a count. Right? So in this case, we would say the total plus equals the grade, and the count plus equals 1, and then the average at the end would be the total divided by the count. So this is another way that we could have implemented exactly the same thing. And that kind of pattern is really, really common. So it's very often the case that we'll have like a variable that we initialize, and then we'll iterate through something, and then based on that iteration for each element within that thing we're iterating through, we will do something to aggregate into that variable. So we'll add up a bunch of numbers. We'll multiply a bunch of numbers. We will count a bunch of characters that exist in a list, right? So here we could try to create a list called passing grades, where we look at all the grades in all the courses that have been input, and now we're going to say that we're going to pick out of that list just the ones where you got a 55 or better. Because remember, a 50 is a pass mark, but it is not a pass mark for the purposes of Engineering 1. In order to be promoted to Term 3, we want to see courses where we don't want to see anything below 55. Or more generally, you can have something that looks, a pattern that kind of looks like this. We have some kind of variable that's going to store an aggregate value, where that aggregate value might be a sum of things, it might be a product of things, it might be a list of things, but we're going to iterate over something, and for each value inside of that iterable thing, we're going to check if something is true. And if that something is true, we're going to do something to this aggregate. We're going to add values to it or multiply values into it or something. This is such a common pattern that we have some special syntax. Just like the compound expression was something that, it's so often we see I is assigned by I plus 1, that is more convenient to write I plus equals 1. Well, similarly, we have some syntax that is commonly used for lists, which I will not require you to write at any point in the course, so you're not going to have to use this syntax, or at least you're not going to have to produce this syntax. I will show it to you, however, and I might expect you to understand it or to be able to read it. So that syntax is called a list comprehension, which I've kind of made a little reference here, an elegant tool for a more civilized age. So a list comprehension is a very terse little syntax for constructing a list out of something else that is iterable. So out of another list, or out of a string, or out of a range, for example. And inside of a list comprehension, we can filter. So we can selectively say, I'm interested in that character and that character and that character and that character, but not the other ones. Or we can say, I'm interested in all the numbers that are divisible by 3, and I can ignore all of the other ones, for example. So sometimes we want to filter, and sometimes we want to transform individual elements. So, for example, if I said, what is so let's find the first 10 squares of even numbers. How would we do such a thing? Or, well, why don't you tell me, what are the first 5 squares of even numbers? Flashlight, crossed swords. I'm afraid I do not understand those emoji. Oh, lightsabers. Ha 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 ha. Oh, very good. Very good. And someone wrote in all caps, Star Wars, in case you didn't get it. The light emoji and the sabers emoji mean Star Wars. Yes, I do get the reference now. Thank you. All right, come on. What are the first 5 squares of even numbers? Okay, 4, 16, 36, 64, 100. That sounds about right to me. So the first 5 even numbers would be 2, and 2 squared is 4. So 2, 4, 6, 8, and 10. There we go. So indeed, those are the first 10 squares. If we wanted to write some Python for that, we might write something like this. So we might say, let's have a list to store the squares. And for I in the range, it starts at 20 and goes up to 21. Now, we could, of course, use the skip counting the skip counting version of range, so 2, comma 21, comma 2. But in this case, I've wanted to break it out a little bit more explicitly and say that we're going to consider every value from 2 inclusive to 21 exclusive, so 2, 3, 4, 5, 6, 7, blah, 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 to 20. And for each of those values, we are going to check, is it divisible by 2? So I modulo 2, what is the remainder of dividing I by 2? And modulus operations we see all the time in programming. So if I modulo 2 is 0, that means there's no remainder when we divide I by 2, which means that I is even. If that's the case, we are going to add I squared to our list of squares. So I times I, or I to the power of 2. So that is how we could find the first 10 squares of even numbers. Now let me show you a much terser, more elegant syntax for doing the same thing. Boom. So you look at this and whoa, there's a lot to understand what's going on here, but that's okay. We're going to walk through this step by step. So a list comprehension allows you to do some neat stuff. So the first thing we're going to see is there's an opening bracket, and at the end there's a closing bracket. So remember, square brackets, round parentheses, curly braces. So we have an opening bracket, and then we have an expression. So that little I times I puts right up front. So the thing that was like deep inside the loop here, all of this stuff here is kind of just mechanics of how we get to the expression that we're actually interested in. And the thing that we're really interested in here is the I times I part, or the I squared part. So in a list comprehension, we put that expression right up front. So that shows us the thing that we're actually most interested in. So we are going to clearly be doing something to do with squares. And I don't just mean me, who won't go to the sock hop or something. All right, so we have an expression, and then next to that we have something that looks like a for loop. So for the loop parameter, the variable that would increment every time in something iterable. So we're kind of like taking the different pieces of this loop and moving them around and putting them all together on one line inside of, or it doesn't have to be on one line, but we're putting them all inside of square brackets in a slightly terser fashion. So that for I in range from 2 to 21 is still there. So for loop parameter in iterable. And then optionally, we can have an if keyword followed by a condition. So what this is saying, and then a closing bracket. So what this list comprehension is saying is for each value of I in this range, if this condition is true, so if I is divisible by 2, then here is a value that we want to add to our new list. So let me type that list comprehension into Thonny, and we'll see what we get. So open bracket. So I'm going to write it as I squared for I in range 221 if I modulo 2 is equal to 0. Okay, so we are going to iterate over this range, and for each element in the range, we're going to check if the value is iterable, and if it is, we're going to take the value I and square it. And look at that. That gives us kind of what we would expect. So here's the square of 2, 4, 6, 8, 10, 12, 14, 16, I guess 324 is 18 squared. That probably is, because I definitely know 144, 196, 256, and 400. So this is probably right too. So you see how this one little elegant line showed us all that. Now, of course, we don't have to use the if condition when we're talking about a range like this. We could use a range that skips by 2 and get exactly the same value. But the reason I did it this way is because I want us to see how we can iterate over something, how we can filter values in the list comprehension. Okay, so let's see, question, do we need the if? No, we don't need the if part. So we could just do this and calculate the same value. So the range in this case is 2, 4, 6, 8, 10, all the way up to 20, as opposed to having the range be 2, 3, 4, 5, 6, 7, 8, and exclude things. So this would actually be the better way to write it, but writing it that way doesn't show off the if part. So I wanted to show you the if part. Cool. Other questions? All right. If not, then remember problem 1 from Project Euler, right? So this is a thing that you've probably done maybe even in a couple of different ways by now. Find the sum of all the multiples of 3 or 5 below 1,000. Well, one way to do that is something that looks like this. So we have a total variable that we initialize with 0, and then for all the values in the range that goes up to 1,000, if that number is divisible by 3, or it's divisible by 5. Oh, and by the way, if a number is divisible by both 3 and 5, so like the number 15, for example, will that be included in this total? Yes, it will, because the or here is an inclusive or. So if this is true, or that is true, or if both are true, then in all 3 of those possibilities, this will evaluate to true, which means that 3 will be included, 5 will be included, 10 will be included, 12 will be included, 9 will be included, and 15 will also be included. So we could write it that way, but we could also write the solution to that problem in this way. So just as a single list comprehension. So we can have, in this case, we're saying we are going to build a list which is composed of all the values in range 1,000 where this condition is true, where it's divisible by 3 or it's divisible by 5. We're going to take that list and we're going to pass it to the sum function to sum it all up. So that is, you can see, a terser, kind of more elegant syntax for calculating something based on generating a new list. So let me see how well we got that by giving you a top hat question. So what does this evaluate to? Going to need a minute to think through that. That's fine. Do 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 do. Oh no, I don't want YouTube to cancel me, so maybe I shouldn't attempt to sing the Jeopardy music. Definitely not sing it badly. All right, some answers are coming in. While they're coming in, I'll just reiterate that once the midterm marks come out, I would, please take a look at your results. And I mean, unless you got every question right, in which case, if you did, then fantastic job. But for anyone who didn't get every single question completely right, there's probably something that you missed or something that you could learn or something that you could look at and say, oh yeah, there was a better way to do that. So please do take a look through it. And your first question should not be, what marks did I lose and should I get back? And let me challenge for the regrade. Your first question is, what things could I have done better? And what can I learn from this? Now, if you do spot something where you say, no, I think I had the right answer here, but you marked me wrong, well, mistakes happen. And so it's possible that you may have done something completely right, but it was mismarked somehow. If that happens, we will open regrade requests, but not right away. So we're going to let you sit with the answers for a couple of days, and then we'll open the regrade request. So if there is something that was mismarked, then we can get it corrected. But your first inclination should not be, I lost 0.5% and I want that 0.5% back. Right? Your first inclination should be, what can I learn from this? All right, so people are typing answers. That's great. So I'm going to go ahead and close this in 5, 4, 3, 2, 1, and close. All right, and let's see what people said. Ooh, we had lots and lots of different answers, but mostly we had the correct answer. So what does this list comprehension do? Well, for each value of I in the range from 1 inclusive to 10 exclusive, counting by 2s. So what does that mean? Well, that means that this is going to construct the list well, to start with, let's just think about the range. So this range would be, if we had a list comprehension that was just I, for I in range 1, 10, 2, that would give us the values 1, 3, 5, 7, and 9. We're just skip counting by twos. But now, instead of just taking that value, we're saying what is 10 integer divide by I for each value in that range. So 10 divided by 1 is 10. 10 divided by 3 in integer math is what? So using integer math, 10 divided by 3 is 3 modulo 1. So this is going to be 10, and then 3, and then 10 divided by 5 is 2, etc., etc. So that list comprehension gives us the values 10, 3, 2, 1, and 1. And then if we sum those up by passing them to the sum function, then we get sum 41. No, we get sum 17. Okay, and most people who answered had that, but there were some different answers. In particular, there was an off by 1. And 17.87. So remember that this was using 2 slashes. So this was using integer math, not floating point math. So there shouldn't be any decimal points. All right. It's also possible to have even more complex list comprehensions, which we will not get into in this course, but you can actually have multi-dimensional things. So you can have, for each row and for each column in a matrix, add up all the values or something, and that's kind of what this looks like. We can have an expression for I in one range, for j in another range, and so we can have more complex list expressions. And if you're interested in that, you can definitely check out the Python language reference, but we're not going to require that for this course. All right, and one other thing that I want to leave you with today. So another really neat thing that will help you with doing things with lists and with strings and with ranges too. Remember the in keyword, right? So we can say for I in range, or for character in a string, or for grade in a list of grades. Well, the in keyword can also be used as an operator, in which case it evaluates to true or false. So it's a binary operator. It has 2 operands. There's a left-hand side and a right-hand side. And the in operator tells you, is the thing on the left-hand side contained in the thing on the right-hand side? So if we had a list of grades that was like 100, 97, 95... and then another 100. Those are some good grades. I could check, is the number 100 in that list? Like so. Or I could say, is 95 in grades? Or is 83 in grades? And now it is false. So in can also be used as an operator that tells you, is the left-hand side value in the iterable thing on the right-hand side? We might say, here's another example. So is John in the name John? Yes, it is. Is John in the name Jonathan? Yes. Is John in the name John Jacob Jingleheimer Schmidt? And the answer is no, because John Jacob Jingleheimer Schmidt spells John differently. But we could use this for other things, like is the character E in the word hello? Or is the character L in the word hello? And this is something that might be helpful for assignment 2, which has now been posted. So if you look at assignment 2, we are going to take all the things that we learned from assignment 1, thinking about how to compare strings and how to have loops that prompt a user for multiple guesses at a word, etc., which most people seem to do quite well with, so that's fantastic. If you didn't do well with assignment 1, then by all means reach out and I can help you understand what you did wrong, and then that'll set you up in a good place where you'll have the understanding and the concepts to be able to do assignment 2. So with assignment 2, we are going to go further. So assignment 1, I said it was going to be like this extremely simplified version of the Wordle game. Well, assignment 2 is going to be basically the real game. So you're going to prompt somebody to provide a word, and then someone's going to guess the word. And when they make guesses at the word, you're going to give them feedback. And that feedback will look just like it does in Wordle, with empty boxes, yellow boxes, and green boxes. How in the world are we going to do this? Well, read all the way to the end, but one little detail that's important is these colored boxes, the empty box, the yellow box, the green box, those are just Unicode characters. So you can put those in a Python string literal, and then you can have 5 green boxes, for example, that you just print out. Do read the details all the way to the end, and please, please, please read through these suggestions. I'm giving you some advice and hints about a way to get started. And one key principle here, whenever we're now getting to the point where the exercising the assignments won't be just trivial, like you can just think of it right away and write it down. There's going to be something that we're going to stop, think about, design. When we do this, don't try to do it all at once. Because if I give you this whole problem, you can say, oh, this seems so overwhelming and I don't know if I'm going to be able to do it. Or alternatively, you'll say, I'm so smart, I'll definitely be able to do that. And you'll write down a whole bunch of code, and then you won't understand what your own code does, and then you won't know how to fix it if it isn't 100% right. Instead, it would be much, much better to try to tackle the problem one bit at a time. Just pick out what's a small piece of this problem that you can solve, and then do the workflow we've talked about. Understand the problem, work through it yourself on paper a couple of times. Then figure out if you can break that into smaller steps that you could explain to someone using a flowchart or pseudocode. And once you've done that, then take that and translate your pseudocode or your flowchart, translate that into Python. So take a small piece of the problem, just bite off a small bit of the problem, work that bit of the problem until you can implement it. Then expand out your horizons a little bit. Say, okay, instead of just this one problem, like how do I check one guess? Now say, okay, how could I repeatedly check a bunch of guesses over and over and over? And then you can solve a bit more and a bit more and a bit more of the problem. And remember that partial solutions get partial credit. So don't come into this saying, I have to design the complete program to be 100% correct the first time. No. First, figure out what is a small part of the problem that you could solve that would get you any marks. Just the smallest, tiniest bit. Like, for example, maybe at the beginning when you prompt player 1 for a word, just prompt player 1 for a word, let them type the word and then say thanks. That's great. Now anybody can do that with the things that we've taught you so far, and that'll get you at least 1 or 2 marks out of 20, right? Probably 3 or 4, in fact. So start with a very small problem, and then once you've figured out how to do that, then bite off a little bit more and bite off a little bit more. It is much better to get 75% on the assignment because you were able to do 3/4 of it than to get 0 because you overwhelmed yourself by saying, oh no, I can't solve the whole problem perfectly 100%, therefore I'm stuck and I can't even get started. No, start with something small. Of course, the other way you can get 0 is by submitting work that is not your own work. And so again, don't panic and say, oh no, I have to get this 100% right. No, you don't. You need to learn from the assignment by doing a little bit and then a little bit more and a little bit more. And it's far better to submit 75% of your own work, or to submit your own work that does 75% of the problem where you've learned a whole bunch, than it is to submit either something that completely doesn't work because you tried to do everything all at the same time, or because you submitted somebody else's work and then consequences ensued. So assignment 2 has been posted. You have like a week and a half to do this. So I would suggest get started soon and get started. Just start thinking about it, right? Just think, what is the small part of the problem and how could I do that on paper to make sure that I understand it, right? These things can feel overwhelming when you read them at first. When you read a huge specification, it's like, oh no, what do I do? But it's even the case for me. So I was meeting with a graduate student yesterday, and he is trying to parse video streams that contain embedded metadata about where a drone is located and which direction its camera is pointing. And there's a specification for this format that's like hundreds of pages long. It's like, how are we going to do this? Well, the answer is start with what is the simplest thing that we could parse, And then what's the next thing that we need to get to the problem that we actually care about? We don't have to be able to play back all videos, etc., etc. We just need to find the part that we need, which means start with something simple, and then I'll add on a little bit more, and then add on a little bit more. And that is a general purpose strategy for problem solving. Break it into smaller parts, and then see which of the smaller parts you can solve first. So this stuff, the in keyword, will probably help you with assignment 2. So the summary of today is, first of all, just how cool are lists? Lists are awesome, right? We love lists. Also, list comprehensions are a really useful tool that can help you write more elegant, more terse code, and sometimes you're very welcome to use them. I may well ask you questions in an exam context or something where I expect you to be able to read a list comprehension and tell me what it means, or to evaluate what would this list comprehension generate or something like that, like we did with that top hat question. But I won't require you to write list comprehensions, okay? So that's our little deal. And then finally, we talked a little bit about the in keyword, which will be helpful for assignment 2. So there's a question here. If player 2 guesses with the wrong number of characters, will that count as an incorrect guess or just a redo? That's a really good question. And I think, yeah, count it as a wrong guess. There we go. All right. So I'm not hearing any other questions popping up, so I guess we will leave it there for today. And I hope you have a lovely midterm break and have an opportunity to change gears just a little bit, and less of the grind of go to this class, this class, this class, and maybe have a moment to take a step back, think more broadly, think about what have we done thus far, where are we going in the rest of the semester, and maybe enjoy a little bit of downtime as well. Make sure you catch up on your sleep and stuff, because we're going to jump back into the second half of the course, learn some new stuff, and have a lot of fun with programming. So I hope you have a great midterm break.